So today we're going to continue talking about chapter 3, and we're going to talk about stoichiometry. So if you remember our little mole map that we used last year in chemistry, so we're using this again to do our stoichiometric conversions. So we always have particles over here in the corner, and remember we use Avogadro's number to get back to moles. Then we have mass. To get from mass to moles, we're going to use our molar mass from the periodic table. And then to get from volume to moles, at STP, remember standard temperature and pressure, we can use the 22.4 liters in 1 mole. So whenever we get a stoichiometric problem, the goal is to get to moles first. So if we can get to moles, we can get to anywhere else on the period, or anywhere else on our conversion chart. Okay? So I was going to start by going from a substance A into some other new substance. And so once we get to moles, then we use our coefficients from our balanced chemical equation to get from moles of one substance to moles of another substance. Okay, so those coefficients out in front that we use to balance. And then we can use Avogadro's number to get from moles to particles again, or our molar mass to get from moles to grams, or back into volume at standard temperature and pressure, we can use 22.4. But remember, we can only use 22.4 if we are going from if we're at standard temperature and pressure. So 0 degrees Celsius and 1 atm. Those are our standard temperatures and pressures. So let's try some examples. So here we have our balanced chemical equation. So we always want to make sure we start with that first. So our first question, how many grams of each product are produced when 1.5 grams of sodium hydroxide fully react? So we're going to start both these problems with our 1.5 grams of NaOH. And we're going to convert that into grams of each of the two products we need. Okay? And you can put one on the bottom if you want, or just leave it blank. So then we're going to multiply by our next conversion factor. So we're in grams, we need to get to grams of our other substance. So let's map out our plane. We're going to go grams to moles using our molar mass of sodium hydroxide. Then we're going to go moles to moles using our balanced chemical equation. And then finally we're going to go moles to grams using the molar mass of the new substance we're going into. Okay, so molar mass, coefficients, molar mass for the new substance. So since grams are on top, so grams of NaOH are going to go on bottom. And then our 1 mole, remember 1 always goes with the mole, of NaOH will go on top. So we need to find the molar mass of sodium hydroxide. So we take 1 sodium plus 1 oxygen plus 1 OH. So here is our periodic table. So sodium, we're going to add one of those together, so 22.99 plus an oxygen, which is 16, plus a hydrogen, 1.007. So we get a molar mass that we're going to plug in down below of 39.997. Okay, so now we're in moles of sodium hydroxide. So if we remember, we're now in moles. We're going to use our balanced chemical equation to do our conversion. So right now we're going to put our moles of sodium hydroxide, which is 2. So if we notice the 2 there. So 2 moles of NaOH. And we're going into our product. So let's just go into sodium sulfate right now. So to 1 mole of Na2, SO4. Okay, and then our last step, we want to get back into grams. So we have our 1 mole of sodium sulfate, that's going to go on bottom. And we're going to put grams of that on top. So we need to find the molar mass for sodium sulfate. So 2 sodiums, 1 sulfur, 4 oxygen. So our sodium is 22.99 times 2, plus the sulfur, which is 32.06, plus 4 oxygen, so 16 times 4. Add them all together, and we're going to get our molar mass, which is 142.04 grams. So finally, to calculate our answer, we're we're going to multiply by everything on top of our fractions and then divide by everything on bottom. So 1.5 divided by 39, oops, that was a third, so 39.9979 plus or times divided by 2, and then times by 142.04. So we get an answer of, I'm going to write the answer up here, 2.66 grams of Na2SO4. So that's half of our answer to our problem. So now we need to do the same thing, except now we're going to go from grams of sodium hydroxide into grams of water. So same step, grams are on top here. So we're going to use our grams and put them on bottom. And it's our molar mass. We've already found that, so we don't need to recalculate that. So I'm just going to transfer down. And our coefficient for sodium hydroxide hasn't changed. It's still 2. Okay, but this time we're going to go into moles of water. So there's a 2 out front of the water. So it's going to be 2 moles of H2O. And then we got to get to grams of H2O. So our 1 mole always goes opposite that. 1 mole, and we got to find our grams of water. So we're going to use our periodic table. So 1 hydrogen, or 2 hydrogens, excuse me. So 1.0079 times 2 plus an oxygen, which is 16. So we get a molar mass for water that is 18.0158. Okay, and then we're going to do our calculations. So multiply by everything on top, divide by everything on bottom. So 1.5 divided by 39.979 divided by 2. Multiply by 2 is not going to change my number, so I'm going to skip over that, and then times by 18.0158. So our other half of our answer would be 0.676 grams of H2O. Okay, so let's try one more problem. So if we have 7.52 grams of water being produced, how much of each reactant was consumed? Okay, so we're going to do the same thing, but we're going to go in reverse. Okay, so now we're starting with water, so 7.57 grams of H2O over 1. Now I'm going from grams to moles of my water. So if you remember our chart, so we're going to follow the same kind of math this time. Mass of water to moles of water to moles of our reactant to grams of our reactant. And I know my molar mass for water, I found it up above, so I'm just going to copy that down. And then we have our 1 mole of H2O. And now we use our coefficients. So let's go from water to sodium hydroxide. So it's 1 or 2 moles of H2O to 2 moles of sodium hydroxide. Now that we're in moles, we want to get to grams. We're going to divide by our moles. Right? Moles of sodium hydroxide on top, so they have to go to the bottom for the next step. And then we're going to multiply by its moles. Okay? So 7.57 divided by 18.015 times by 39.971. So we get a final answer of 16.8 grams of NaOH. Sorry about all the emails. So that would be our answer. And then we could do the same thing, but we're going to repeat it with to go to the other one. If you want to give that one a try, you can.